Hello, Carlos. Today, I was not very successful with my onset detection, but I still want to tell you about it because I think what I did was still kind of cool and maybe I will still work something out about it. So this is the beginning of a new idea. What you are seeing here is the video Wavelets, a mathematical microscope by Artem Kirzanov, and this video explains how to implement wavelets and what they are being used for. I think it's a very recommendable video. It explains a very complicated topic in the easiest way imaginable with a lot of great visualizations, as you can see when I'm scrolling through here. I watched this and I decided to also implement wavelets because something about this reminded me of my onset detection. First of all, there are a lot of axioms already, which is like hard-coded values, especially the default values are meaningful because at some point when I implement the onset detection, I don't want there to be like 10 different parameters that the user has to set up, because literally all plugins that have onset detection only give you like 3 parameters or something, and most of them don't even have something to do with the quality of the onset detection. So this is like very overkill right now, and I'm trying to reduce parameters, and one of those parameters is called hold, and currently holds defaults on 24 milliseconds, as you can see, and the hold parameter defines how long after an onset has been found there cannot be another onset. So one onset, boom, then 24 seconds pass, and then after that time a new onset can appear. I just thought, like, why don't we give it a try? Because wavelets are known to highlight the energy that is going on at a certain frequency. So I was thinking to myself, like, what if a 16th note is a frequency or an 8th note? What if I just have 2 wavelets? So this is one wavelet, by the way, it has a certain size. It is an array of complex floats, and there is a magnitude value here and an index and the length, because this is kind of a FIFO thing. And then the processing is like this, like going through the buffer, calculating the wavelet thing, the ABS of sample times wavelet. I guess that is how wavelets work. I hope so, at least, because ABS on complex numbers gives you the magnitude of the arrow that you would see if you were looking at the 2-dimensional representation of complex numbers. Again, this is better described in this video if you want to have a good explanation for that, but I interpreted it to work like this. I hope it's correct. If not, let me know in the comments, please. I try to get the max magnitude out of this, and then when I've reached the size, I'm using the callback to communicate the magnitude to some other place before setting it back to 0 so that this process can start off fresh. And the wavelength itself, it just uses a so-called Morlet window, which is being calculated like this, and cosine and sine waves for the complex values. So I suppose that works like this. And now we have this class called rhythm wavelet, and that implements the 2 callbacks of the 8th and 16th wavelet. Because I just wanted to know, like, if the signal that I'm currently working with has more energy on the 8th notes or more on the 16th notes. So if I was having like a Hyatt situation, then it should go more to 16th, but if it was like a full drum set, then it would be more on the 8th side. And in accordance to that, it could set up the hold parameter to be long enough so that it actually does not find any transients in between. And maybe it could also be used on a decay parameter, I don't know. So yeah, I did that, and as you can see, I have some debug messages here, and I already printed them out a little bit earlier. I will still show you what they currently yield, but before that I will go on. You can set the BPM, you can update the wavelets, which looks like this, calculating the length of a beat in samples, and then what would be an 8th and a 16th sample, and then saying, okay, this is the length of these wavelets. And this is the wavelet callback in general, which is basically just saying whatever length comes out of this rhythm wavelet thingy is now the length of the hold processor. Well, at least half of it, because I don't want it to miss a transient either. And that's it. I currently disable the hold parameter so that it does not interfere with this logic, and the wavelet thing is calculated on the buffer after I have copied the input audio into the buffer while also reducing it to its mid content. So no mid side, just mid. And yeah, I will show you what that looks like now. Boom boom boom, chukka toom, tak 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 So as you can see, the values are quite random. Sometimes they approach 0.5, other times they are just going towards 0 or something. Now, obviously, this is kind of weird now because we are not in the context of a DAW. I think I set a default BPM of 120 for my standalone projects, but I'm not quite sure. Doesn't matter. I can just say I have already tested it in the DAW where the values were always going somewhere between 0.3 and 0.5, and it was alternating which one of these is the higher one. There didn't seem to be like a clear logic. It was kind of random. It did not come with the expected beats when I tried them, so that doesn't work yet.